students. Today we will discuss about the basic properties that are associated with the charges and see how the charges are generated. In my previous lecture I have already told you that charges cannot be created but merely transferred from one body to another body. Suppose that we have two insulating bodies, one is glass rod, another is silk. Now we are rubbing the glass rod with the silk cloth. Some electrons will transfer from glass rod to the silk. This plus sign shows the deficiency of electrons and this minus sign shows that there is a presence of electrons. As you can see that the number of electrons lost by this glass rod are similar in amount that are the electrons which are gained by the silk cloth. So in turn we can also see that charges remains conserved, means the charges lost by one body is equal to the charges gained by the another. Now moving on, how these charges are transferred? I have said that we have rubbed the glass rod with the silk. Now a question arises, by doing so we generated the charge? No. We can never generate the charges, we merely transfer the charges from two insulating bodies to another that are separated by some insulating medium. Here is air present. Now we have, in rubbing, we have done some external work, means this energy in turn helps the charges to move from this glass rod to silk cloth. So this statement also satisfies the basic law of conservation of energy, means energy is not wasted here, not lost by, but it is used in transferring the charges from this glass rod to the silk. Now the amount is same, charge is conserved. Now some more properties that can be seen on the board, means charges we cannot create the charges, we merely transfer. Now a question arises, from which body the charge will transfer? Maybe from silk or glass rod. How we will decide? A very scientific term, which is a work function, that decide the terminology associated with the transfer of the electrons. Means a body which has lower work function will transfer its electron to the body having higher work function. Now a question again arises, what is work function? Work function is basically the minimum amount of energy required by any material or matter to just eject an electron. In radiation we will discuss about work function in much more detail. So another property here comes out that electrons are transferred from the body whose work function is lower to the body whose work function is higher. Here the work function of silk is higher than the glass rod. That's why the electrons are transferred from the glass rod to the silk. Now due to rubbing, electrons are transferred because we have done some external work. This proves the law of conservation of energy, means in this way the law of conservation of energy holds. And the last one property is that the mass of negatively charged silk, where there are electrons, means the mass of silk will increase as it contains electron, and the mass of glass rod will decrease as it loses its electron. Electrons has some mass is equal to 9.1 into 10 to the power minus 31 kg. So this amount of mass is negligible, so we cannot feel in a real world with such a kind of transformation of electrons from one body to another. We are now in the world of electrostatics, means by rubbing we have created a charge which is at rest, and its study is contained in electrostatics, means frictional electricity, means the charges are studied in electrostatics, and when this charges moves, this creates another terminology which is current electricity. Later on we will discuss about current electricity. Focusing on electrostatics, we can simply give some importance of electrostatics. Why we study charges at rest? In our daily life, in many fields we use this electrostatic phenomena, means charges at rest. Suppose that there are some electrostatic generators. Electrostatic generators are the device which can produce voltages at very high level, means of the order of 10 to the power 6 volts. Such high voltages are required in X-rays work and nuclear bombardment. So this one is the application of electrostatics, and secondly we use the principles of electrostatics for spray of paints, powder, etc., etc. In motor vehicles, electrolytic paints are over there on the bodies. And the third one is that the principles of electrostatics are used to prevent pollution. In reducing the pollution, we also use the principles of electrostatics. And the last one is that the development of lightning rod and capacitors are the main outcomes of electrostatics. So in all these things, you are now much familiar with the term that electrostatics, why we need electrostatics. Now another question arises, what is all about the charge and its unit? In one word, we can define the charge. Charge is a characteristic developed on the matter by which it can apply a force, whether it is attractive or repulsive, depending upon the pair of the charges that are involved. If there are two positive, then they will repel, and if there are one positive and one negative, it will attract. Means charge is a characteristic developed on the matter due to which it can apply a force. And in the last lecture I have also told you that for a charge to exist, matter is necessary, compulsory. Now we will, in our next lecture, we will see what is the unit of charge, how much electrons are contained in that unit, and all these phenomena associated with the charge, like conservation of charge, quantization of charge, and some more phenomena. So guys, please like my video, share and subscribe. Thank you.